It's kind of wild to think that the carbon atoms that make you might have been part of a dinosaur once, or that the water you're drinking today has been on this planet for billions of years. It's not science fiction, it's absolutely true. Our planet is the ultimate recycling program, and we're going to take a look at how it all works. Okay, let's get into it.
So that brings up a really big question, right? Life needs certain essential elements, the basic building blocks for things like DNA and proteins. But here's the thing, organisms can't just make them from scratch, and they don't really get used up either. So where does all this stuff come from, and how does that supply chain shape, well, everything?
Well, the answer lies in something with a very long, very sciencey name: biogeochemical cycles. But don't let the words scare you. The idea is actually pretty simple. Just think of them as these giant closed loops. They're constantly passing elements like carbon and nitrogen from the air and the earth into living things and then right back out again.
I love this water wheel image because it makes a crucial point really clear. You have to understand the difference between how energy and matter move. Energy, that's like the water flowing over the wheel. It flows through the system, one way. But matter is like the wheel itself. It gets recycled within the system, going around and around, being used over and over again.
So if our planet is running this huge recycling program, what's actually powering it? What are the forces that keep all this matter moving? Well, we can break it down into 4 main drivers.
First up, you've got biological processes. This is basically just life doing its thing, eating, breathing, growing, decomposing. Every single living creature is part of this. And then, on a totally different scale, you have the massive power of geological processes. We're talking volcanoes erupting or rocks forming over millions of years. These move matter on a truly planetary scale.
On top of that, you've got chemical and physical processes, things like rain falling, clouds forming, even a bolt of lightning can play a role. And finally, there's us, human activities, things like farming, building cities, burning fossil fuels. We've become a major force that is actively changing these ancient global cycles. All right, so let's follow the journey of one of these elements. And we'll start with one we all know and love, water. Let's imagine we could tag a single H2O molecule and just watch where it goes.
And here it is, the water cycle in all its glory. It's always in motion. It's this incredible journey from the ocean up into the clouds, over land, and back to the ocean again. You can think of it like a giant circulatory system for the whole planet. And yeah, we're definitely part of it.
So how does water get up into the atmosphere in the first place? Well, it happens in 2 main ways. You've got your basic evaporation, right? Water turning to vapor from lakes and oceans. But then you have this other really cool way called transpiration. That's basically water vapor being released from the leaves of plants. It's like a biological pump, constantly pushing moisture up into the sky.
Okay, time for our next stop on the tour. If water is the bloodstream of the biosphere, then you can think of carbon as its skeleton. It is, without a doubt, the absolute backbone of all life as we know it.
And this diagram really shows you just how central carbon is to, well, everything. It's a key ingredient in all the major molecules that make you, your carbs, fats, proteins, and even the nucleic acids in your DNA. Seriously, without the constant cycling of carbon, life just couldn't exist.
And of course, since it's a cycle, carbon doesn't just get used by life, it has to be released back too. That happens naturally through things like respiration. Yep, you're doing it right now just by breathing, and from volcanoes. But it also happens through human activities, especially burning fossil fuels, which takes carbon that was stored for millions of years and puts it right back into the atmosphere.
All right, next up are 2 more superstar nutrients, nitrogen and phosphorus. They are both absolutely essential for life to exist, but they have a really fascinating twist. They're often super hard to get.
Let's start with nitrogen. Now, get ready for this because it's a bit of a mind bender. 78% of the air you are breathing right now is pure nitrogen gas, so it's everywhere. But here's the catch. For almost all living things, that nitrogen is completely unusable. It's like being stranded in the middle of the ocean, surrounded by water, but dying of thirst.
So how does life get around this problem? Well, it relies on some tiny, microscopic wizards. There are certain types of bacteria that can perform a kind of chemical magic trick called nitrogen fixation. They grab that unusable nitrogen from the air and convert it into forms that plants can actually absorb. Without these little bacteria, the entire global food web would just grind to a halt.
And then we have phosphorus, which you need to build DNA and RNA.
But its cycle is totally different from the others. See, it doesn't really involve the atmosphere. Almost all of the world's phosphorus is locked up in rocks and soil, and it only gets released very, very slowly as those rocks weather away. This makes it an incredibly precious and often very scarce resource.
Okay, so we've got these incredible, grand cycles moving all these essential nutrients around the globe. But what does that actually mean? Why should you care? Well, it turns out these cycles set the fundamental speed limit for life itself.
And this brings us to a really important idea, the limiting nutrient. Think about it like you're baking a cake. If the recipe calls for flour, sugar, and eggs, but you only have one egg, it doesn't matter how much flour and sugar you have, you can only make a one-egg-sized cake. The egg is your limiting ingredient. In an ecosystem, the limiting nutrient is that one element in the shortest supply that holds everything else back.
This gear analogy is just perfect. For an ecosystem to run at full steam, all the nutrient gears, nitrogen, phosphorus, potassium, you name it, they all have to be turning together. But if just one of those gears gets stuck, if one of them is in short supply, the whole machine slows down, or just stops completely. So that's the natural balance of things. But here's the multi-million-dollar question. What happens when we humans come along and just dump a massive amount of that one limiting nutrient into an ecosystem that's always had to live with scarcity?
Well, here's the cause in action. Runoff from farms using a lot of fertilizer often carries huge amounts of nitrogen and phosphorus, the very things that are normally limited in places like lakes and rivers, and washes it straight into the water.
And here's the effect. That sudden flood of nutrients is like an all-you-can-eat buffet for the algae in the water. With their main limitation suddenly gone, they just go wild and their population explodes. You get what's called an algal bloom, which can choke the water, block sunlight, and throw the entire ecosystem completely out of whack.
So, as we start to wrap this up, let's just come back to this one central amazing idea. Our planet's life support systems are built on these incredible, interconnected cycles that pass the very same atoms of water, carbon, and nitrogen around and around through all of time.
Which leaves us with one final, pretty heavy question. For billions of years, these cycles have maintained a delicate balance. But now, we humanity have become a major force shaping them. So the real question for our future is, how will Earth's ancient recycling programs respond as our human footprint continues to change the planet?